All right, good afternoon, everyone, and thank you for joining this session. So before we get started, this is going to focus a lot on OSCAL, so I just wanted to get a sense of, anybody has heard about OSCAL? Oh, okay. Anybody has worked with it? A little bit? Okay. All right, so I'm going to cover a little bit mostly about OSCAL and kind of what it is and what you can do with it, and we'll go through that today. All right, so fundamentally, I think all of you are aware of this. The ATO process is quite arduous. As soon as you see the word, say the word ATO, you get grins, right? And it is necessary. Unfortunately, we're not going to get away with it, and it is going to be here forever. And so FedRAMP, one of the GSA agencies that authorizes commercial SaaS products for federal government use, is now up to 300 plus authorized systems, 100 of which just came in last year. And that volume continues to grow because the government is starting to use a lot of commercial products. And that trend is not going to slow down. And so you have to go through an authorization, you have to go through an annual assessment, and you have to do monthly ConMon. And just imagine 300 plus packages coming into FedRAMP every month in Word and Excel. And they have to sift through all of that information, review the information, adjudicate on it, and manage that, and that just requires a lot of people. That's not sustainable, and it is not scalable. And so FedRAMP joined hands with NIST a few years ago and started to draft OSCAL as a standard, and what they really want to do is get all of this content out of Word and Excel into a standardized format that is machine readable. And why do we do this? So as NIST started to work on this, 2 years ago, OSCAL was baselined at 1.0, and today it is up to 1.1.4, and it continues to improve at a pretty good progressive speed. FedRAMP was the primary agency that went all in, has helped OSCAL be where it is today, and so where it is today, it is very uniquely inclined towards U.S. federal government ATO requirements. There is agencies in Europe that are looking at it for other kinds of cloud services authorization, and the agencies in Australia have also started to publish their controls in OSCAL format as well. So OSCAL is really designed to move all of the control-based compliance work into a machine-readable format, so it is designed not just for cybersecurity, 853 per se, it is also designed to be applied to HIPAA, ISO, all of the other standards. That's the intent of NIST. Although it is heavily influenced with RMF at this point, and heavily influenced with 853, and heavily influenced with the US federal government requirements, but the intent of OSCAL is really to support all control-based regulatory frameworks. And if anybody has been authorizing systems, you know you have to do US federal compliance, then you have to do SOC 2, and then sometimes you have to do PCI or DOD IL, and it's largely the same stuff that you have to do again and again and again. And so OSCAL will really help for you to be able to do all of that. And also if you have your cross-mapping between these regulatory frameworks, you can then apply your evidence and findings across multiple frameworks. It's hard to do that when you have Word and Excel. It's going to become much easier to do that once the standard comes out. So I'm going to take a little bit of a deep dive into what OSCAL is. So I'm hoping everybody's familiar with RMF. So if you look at RMF, OSCAL maps directly to every step of RMF. So from a prepare standpoint, all of your control definitions are defined in a catalog. And those catalogs typically should be published by an authoritative agency. So NIST, for this purpose, has authored 853 in OSCAL format. They merged 853 and 53A, so you have both control guidance and assessment objectives all merged into a single artifact, and that is the 853, both Rev 4 and Rev 5. ISO, we understand, is working towards publishing their 27K into OSCAL as well. The others are not quite out yet. PCI DSS or HIPAA has not moved in that direction, but the intent is to go there. So now all of your control definitions and your parameters, requirements, and guidance is now available in a machine-readable format. And then from a select standpoint, NIST has published FISMA baselines for low, moderate, and high based on your FIPS 199 categorization. FedRAMP, on the other side, has also published their own baselines, and they're significantly different from the FISMA baselines. FedRAMP is far more rigorous and has very, very strict guidelines in terms of granularity at which documentation must be provided and granularity at which the assessments must be conducted. And all of those directives are now represented in this OSCAL file. So a lot of tooling can now be done to take this information and start to automate some of these things. So all of these baselines are available, again, for 853 specifically at this point, both Rev 4 and Rev 5. And then you have your infamous SSP. So now you can represent the entire SSP as well in OSCAL format, which could be an XML, it could be a JSON, or it could be a YAML. You can choose whichever representation you like, but you can now start representing a full SSP as well. There are initiatives underway with the hyperclouds right now. They're building their platforms such that your technology components can start expressing your control implementations. So aspects of the SSP can be automatically built based on what your technology stack is. And then, of course, from the assess and authorize side, we have a document artifact for an assessment plan. We have an artifact for assessment results, and then the POA&M. The POA&M and the results is very much aligned at that point. So we have now machine-readable representations of these artifacts. What they've also gone ahead and done is define something called components. And so if anybody has built SSPs in the past, you know the arduous process that goes into doing that. Countless interviews with the tech teams. The ISSO has to go and learn about the tech stack, understand what's going on. Now, this was a little bit easier to do when you were in a controlled environment. So let's say you're an agency or a directorate or an office, and you had the old world of the on-prem system. So you really had a managed services team that managed the data center, that managed the stack. The app dev just came in and built the app. And so you had a GSS from which you could inherit a whole lot of controls. And you could inherit your physical security controls, corporate policy and procedures controls. If you have a NOC, if you have log management tools and audit tools, single sign-on. There's a lot of stuff that the app dev could inherit. But still, it was a fairly monolithic environment and you had pretty much full control of it. Now take that into the cloud world and think, from FedRAMP's perspective, you have a variety of multi-stakeholder models now. I mean, a lot of SaaS products are multi-cloud. They're not even single cloud. So now you're talking about multiple cloud services, multiple clouds, multiple technologies, single sign-on is hosted. So a solution today that is SaaS-based is comprised of multiple solutions that are SaaS-based. And now try to build an SSP and try to understand the control inheritance model with all of that technology that is being used. It just starts to become everly complex. And so, of course, everybody's taking steps in kind of simplifying it by creating pre-built stacks, predefined SSPs, and you can start inheriting. But that means you're copying things and you're making multiple copies, and really you're starting to just make it more complicated. So the component definition is a concept where when you're leveraging a package or you're leveraging another system and you're going to be inheriting controls from that system, you do not have to have access to the SSP of that system. The SSP is a private implementation of that system. That is how they have implemented the controls, but that's not necessarily how you inherit those controls. So the component definition is like a proxy document that a leveraged system can offer to a leveraging system and say, here's how we offer implementations of these controls. You can now include that into your SSP. Today, typically an SSP just refers to the leverage package and says, hey, I'm going to inherit this from this party. So for example, if you're in hypercloud physical security, you're going to inherit from AWS or Azure or whoever, right? And you just make a statement saying, I'm going to inherit this from AWS. Now somebody has to go read that package and kind of figure out, okay, how have they done it? Does that meet your requirements or not? Or if you're single sign-on and you're using Okta, you got to do that. It becomes arduous for the reviewers at that point. And so what component definitions really does is allows you to publish your publicly available control implementations so that inheriting systems can do that. And what that really allows you to do is allows you to start assembling your documentation in an automated fashion. So, you know, if you're in an agency, you know your ISOs do this today. They know the systems, they know similar systems, they have the GSS. There's a lot of copy and paste that goes on. And now you can just eliminate that and kind of automate that. So, and then the downstream vision, obviously, of OSCAL is that you're now able to represent your system characteristics. You can represent your inventory. You can represent a whole lot of information in a machine-readable format so that you can inject that into a CI/CD pipeline. And potentially in the future, you can start automating the assessment process, at least of the technical controls, on an ongoing basis. So if you have a CI/CD pipeline running, you have a container that spins up, and you have an SSP that defines what ports and protocols we're using in this component, you know, you have assessment tools that can test for compliance on that container, provide an adjudication online, and be able to decide whether you want this container to be released or not. And so compliance now has a seat at the table from a continuous standpoint. I mean, even today when assessments are done, or technical assessments, right, we do them on an annual basis, and we do a monthly Kanban, and you scan your inventory. Frankly, half an hour after you scan your inventory, it's obsolete. Because in a hypercloud environment, you're spinning up and down on a constant basis. I mean, next day your inventory is obsolete, good portions of it. So whatever you scan today may not be relevant tomorrow, or may not be relevant 3 days from now. So even though you're doing monthly Kanban and you've brought the granularity down from annual to monthly, it's still not continuous. It's more frequent. It's definitely more frequent, but it is also arduous. It is very manual intensive. So how do you get to the point of continuous compliance? And so the intent of OSCAL here is to become the data fabric that can be used with a standardized information expression model so that you can now start injecting this into your build and deployment processes as we go. And that's the pipe dream. That's where we want to get to eventually. So I'm going to peel this onion a little bit more. So let's get into OSCAL. What does it look like? So on the left, you see we have catalogs, and catalogs are control definitions. So 853 Rev 4, Rev 5 has been published by NIST. It is available on their website. And then you have profiles. Profiles are your baselines. And what your baselines are doing is pulling controls, and it could come from multiple catalogs. So if you have a system that is a financial system, high value asset, and it is, has PII, and possibly it has, PHI, you can pull controls from multiple frameworks and build your baseline from that perspective. For right now, NIST and FedRAMP have published their baselines for moderate, high, low, and low SAS as well. From those profiles, then you tailor to your system, and you build another profile that is now representative of your specific system. And all this can be done with drag and drop because everything is in a machine-readable format now. Now from that baseline, that becomes essentially the contract for the IT system. You're supposed to be complying to that baseline. So you start building your SSP, we can build out a template SSP based on that baseline automatically and say, all right, app devs, here's what you need to provide in terms of controls because this is what the baseline is. And you can also define the granularity at which you need to define these controls. So, from organization to organization, there's a preference, right? And some folks document it at the control level, some have to document it at the parts level. And you might want it done differently for different things. Likewise with assessments. Some organizations want the assessment done at the control level. Some really want to do it at the individual objectives level, and they want it documented at a level. So all those directives are now embedded into the profile. So tooling can automatically generate your SSP template and automatically generate your SARS, assessment report templates, so that the content that requires need to be provided is automatically defined. And now the assessors or the documenters just need to go in and start filling it out. Likewise, information from the SSP flows down into the SAP, which is your plan. And you can have multiple different plans. You can have the annual plan, You can have the monthly plan. You can have different kinds of plans that you define. Once you define a plan, you've selected the list of controls that you're going to test, the subjects that you're going to test, what tasks you're going to conduct. All of that can now be defined in a machine-readable format. And the idea of that is somewhere down the road, you can take some of these tasks and have implementations for them, automated implementations that can go out. So for example, if you have policies and procedures, there are policy checking tools out there that will go look at your configuration and know whether it's meeting your policies or not. And so the idea is that now this information can flow through. And likewise, you have your SAR, which is your assessment results, where your findings and observations are documented. Even though there's a good amount of technical controls that can be automatically assessed, so if you're running scans, you can take your scans and convert the scan data back into SAR findings automatically. There's still a lot of manual controls, and you still have to do a lot of manual assessments. Still, that's not going away. And so, but you can bring it back and document it in the SAR format. The SAR in OSCAL also has a full risk model built out. So when you do an assessment and you have findings that are failing, you are required to document the risk of that failure. And those risks need to be mitigated during the assessment process. And any risks that are not resolved during the assessment process can be posted into the POA&M. And from that point onwards, they live in the POA&M. So the POA&M artifact is a little bit lightweight. It really just has the risk object into it. We do not have an OSCAL artifact for the authorization document itself yet, but NIST is working on it at this point. All right. So now let's assume, how does this help in document creation? So here's an example. If you do, this kind of happens. It's been happening out there today. If you go to various agencies, you'll say, we've got these templates. And if it's a system of this kind, we have a sample SSP. We have control implementations already done. So there are individuals that are copying and pasting, and they kind of have this institutional knowledge in their head. And so if you have a new system that's going out and you don't want to get it out quick, you know the ISO you're going to go to, who pretty much knows the other systems of the agency. He knows where to pull the data. He's going to go pull it and boom, get it done for you. Now you can actually automate this process. So if you do that, you take your GSSs and other common controls, you can model them into a registry. And sometimes these models are aligned with control families, sometimes they're aligned with capabilities. Particularly in an agency or organization, if you have a managed services team that is offering a lot of services. So if you have an organization that builds out the cloud enclave, has stood up log management, single sign-on, and other kinds of features that are available to app dev, all of those controls can be built out into a component registry. And those controls can also now be referenced for different frameworks. So let's say, this is happening with commercial CSPs, they have one product, and they're selling that product to the federal government, state, local, Department of Defense. Everybody has a separate regulatory compliance requirement. FedRAMP has FedRAMP, and then you have StateRAMP, and then you have DOD IL4, 5. I mean, everybody's different. So now what they're doing is basically saying, this is how I do single sign-on, and I'm going to build a component for single sign-on, and I'm going to write how I meet the control requirement for every framework within that component, right? So you've centralized all of your control implementation information, and it is in one place, and that is your component. Now I need to go for FedRAMP authorization. I need to build a FedRAMP moderate SSP. I have already said I am using this component, so tools can automatically build that SSP for you. Right, so we can now take all of that control implementation for a FedRAMP moderate, automatically copy that into the SSP, and your SSP draft is ready to go. Right. And if you look at any system in the cloud world, more so than others, you're not really building a lot. You're assembling a lot. You're assembling and configuring a lot of services. You're really not writing as much code as we used to back in the on-prem days. And so this becomes even more relevant in that case, because if you do model your controls, and frankly, this is happening today. If you go into the agencies and groups and mature organizations, they've done this, but it's in Excel spreadsheets, or it's kind of in different formats. It's just not available in a standardized format. Now you can put that in a standardized format, and then tooling can be built that is going to help automate all of that for you. So that's exactly what happens. Our infamous AC1. This is an example. So in your access and control policies and procedures component, you can define your control implementation for a moderate, for a high. High will have additional requirements. It's going to have different parameter requirements. And then for IL4, you're going to have some different requirements that you need to meet. And you can document all of that into a single place. And you can build out your different SSPs in an automated fashion. How does this help in the long run? Now your inventory is also going to be in a machine-readable format. So when you do build out your SSP, you're doing your authorization boundary, you are required to define all your ingress and egress points. You're supposed to define all the ports and protocols that you're accessing outside the authorization boundary. So a lot of that information is now available in machine-readable format. So if you have your password attempt policies, that is now documented here. You can now inject all of that information into a CI/CD pipeline, so your assessment tools can now access this information. And again, the idea here is when you write the SSP, you're really saying this is how I intend to be compliant. And because you said this is how I'm going to do it, the assessment tool can now come in and say, all right, let me see how you're going to do it, and I can now run the tests and tell you whether you are doing it or not. And this now includes your entire tech stack, so you're required to identify all the services you're using, all the ports, all the protocols, endpoints, and everything. So you're also kind of heading a little bit towards the SBOM requirement, right, from a supply chain perspective. I mean, we all know when Log4j happened, right? The very first question that the CIO was asked, what is our risk? The first person he went and asked, where are we using Log4j? And the first person said, I have no idea. Right? Because you don't have an SBOM. Frankly, you don't even know in a large extent. So now a data call goes out, right? And everybody's scrambling, everybody's trying to figure out where are we using it? What are we using that is using it? I don't even know that, right? So the infamous statement, you don't know what you don't know. And so now what happens is you figure it out. You figure out where Log4j is being used. The next question becomes, what does it mean? Is it on the front end? Is it on the back end? Is it in the secured enclave? You need context. Where is it being used? Because your risk is different. Your risk is different depending upon where it is being used and how it is being used. Now you got to figure out the risk, right? And once you figured out the risk, now the CIO can respond to the question, what is our exposure? And look at the amount of time that takes. By moving to a standard like this, you will force the organization to start documenting this far upfront and is machine readable. And so if all of those SSPs are true to their fact and they're built by expression of the components, then you do automatically have all of the data, and it's a matter of running data queries. Right? And you can now start injecting a lot of this information into CI/CD pipelines. So you're not just doing security checks, you're also doing compliance checks. Right? As much as you do need to be secure, unfortunately, you need to be compliant as well. Right? And so as much as we hate the compliance side of things, but it's still necessary. It's not going away, and you're going to have to keep it, and you're going to have to do it, and you're going to have to do it faster, and you're going to have to do it quicker, and you need near real-time view of these risks, right? Not just vulnerabilities, right? It's not about finding a vulnerability and fixing it. When you find a vulnerability, the executives need context. What is the risk? You need to get to risk quickly. You cannot. So if I run a Kanban on a monthly basis, frankly, I don't know what risk I'm sitting on until the next Kanban. That's, in the cloud world, that's the reality, right? Everything is changing so rapidly. And you're built on multiple layers, and you don't know who in those layers has a vulnerability and what risk does that pose to you. It's, frankly, you're just running in blind right now. And so the idea really here is, and we're not going to get here overnight. It's not going to happen overnight. Compliance processes are not going to get re-engineered overnight, and nobody's going to fund it. So it will take time. But the idea of OSCAL is really to start the process so that you can get to that point. Unfortunately, because the data pipeline is linear, you would love to get to the right end and get the benefit of that automation, but you can't get to it if you don't start on the left. So your SSP conversions are really the most important thing, and you have to get started with that. If you don't start with that, you're never going to get to the other end. There's a lot of organizations that have tried it. So you'll find a lot of tools out there that says, I can take a scan file, I can convert that into observations and findings in OSCAL format, and I can spit it out. Okay, great. Where are you going to put it? You don't have an SSP, you don't have an SAP, you don't have a SAR, you don't have a GRC tool, you don't have somewhere to put it. What are you going to do with this JSON scriptlet, you know? And so it doesn't deliver value. But unfortunately, you have to start from the left. That's good. So what does this help in end of the day? The value here really is compliance documentation. As much as we hate it, as much as arduous it is, it still needs to get done. It just has to get done. There's no way around it. And so you're really starting to automate the assembly. And at one of our conferences, Google presented the project that they have done, and they've really pushed the limit on this to the point that their software factory now produces SSP parts in an automated fashion, and it transmits them into the network in OSCAL. And then they have a GRC collector that collects all of this information, assembles the SSPs for these systems automatically. They've really pushed the limit to the other end. But that's the vision. That is the vision, that you can get to a point that you build a component. You can, at that point, put your control implementations as well and have it transmitted. And the receivers can now start picking it up. You improve the quality of your documentation. As much as everybody says we'd like to produce better quality document, we just don't put effort into it, right? It's not something that gets funded. And you just tell the resources to work harder, do more work, do it better. But there's really no other way to do it. And so by documenting this in a component registry, you have your higher value people really focusing on the quality of the document, not the production of the document. The production is now automated. And you can move your folks to be really working on higher value work, like look at your risks, So we really want to automate all of that mundane that resources are buried under and move them to working on more high value work. We also need to improve the interoperability of these documents, right? I mean, right now, everything is buried in Word and Excel. Some folks have some GRC tools, but they're very specialized to either SOC 2, or they're specialized to ATO, or they're specialized to particular framework. The idea really is this information needs to become interoperable. And a lot of this is really being pushed by the hyperclouds. I mean, imagine AWS and Azure, how many regulatory frameworks they need to comply with. I mean, even a single S3 service has to comply to umpteen amount worldwide, right? How do you build that documentation and how do you really express it? And so it's imperative for them to move in this direction as well. For your assessments, you can start automating a whole lot of assessments. I think the biggest pain we hear in the market is you get all these scan files. Great, you can scan and identify vulnerabilities, but moving from vulnerability to risk assessment is still a very manual process. And it requires higher value people that are going to interpret this information and really figure out what's going on. So you need to start automating that process as well. And then it really gets you to dynamic inventory, right? Once you're in cloud, you have a dynamic inventory. You do not have a static tech stack anymore. And so how do you maintain compliance for a dynamic inventory? And so you have to move in this direction so that everything can be automated. And you do need to assess more often, right? And I mean, with this whole supply chain issue and SBOM, you don't know what is injecting risk into your IT system because, people are downloading libraries, they're assembling everything very quickly, and the speed of development has become neck-breaking at this point, especially in the cloud world. How do you ensure that, your risk is assessed in a timely fashion? Are you going too long and you're going to find out when you're going to find out? So from a risk management perspective also, we're looking to automate findings to risk, right? So once you have a finding, okay, we found it, that's great. What does it mean? Now, you're going to have a lot of findings, but you probably don't have resources to tackle every finding. You're going to have to prioritize. How do you prioritize? You cannot prioritize without understanding the context of finding, what is the risk I'm taking. And so you have to get from finding to risk very quickly so you can prioritize it and go ahead and fix it from that perspective. Not every finding gets fixed. Not everything gets fixed. You got to fix the stuff that has the highest risk. And so you're going to improve the timeline of your risk management, right? So you're going to close that window, make it smaller and smaller and smaller. Particularly in the government space, now you're going to be required to report everything to DHS, right? Through the CDM. And so when that happens, you know, their requirement of granularity is going to continue to increase. I want to know it sooner. I want to know all of it. I don't want you to just tell me what you tell me, because you don't know what I know. I need to see everything so that I can decide whether there's a threat or not. A threat is not typically, you know, singular. It doesn't just come from one source. It's happening in a lot of places, and the collective action is really what needs to be found. One specific point does not have full context. And so that is going to drive the need for automation, standardization, so that, you know, parties that are receiving this information can process the information and make sense of it as fast as they're getting it. All right, so I'm going to dive a little bit deeper to, you know, anybody that's really interested in how does all this work literally on the ground. So on the left-hand side, you can see there's a catalog, right? Catalog is where you have your control definition, and then you have your profile where you have your baseline representation, and you have all the directives embedded in there in terms of how the documentation needs to be created. And so what we do is we take all of that information, we auto-generate an SSP template, and what we're basically doing in OSCAL is building out all of the placeholders where your control implementation details need to go. So within a matter of seconds, I can spit out a, you know, SSP template which is uniquely tailored specifically to this particular system and the baseline that you're looking to satisfy. And again, if you have already defined it in component definitions, you pull that in and you can populate that document automatically. Now information can be pulled from the baseline into the assessment plan, right? Your assessment plan is going back to the baseline. It's not going off the SSP. I don't trust the SSP, right? My job is to assess you against a baseline, not what you said you're doing, right? So now we can take the baseline and automatically build out an assessment plan and be able to explain. So now when you pull out your controls that need to be assessed, you can create plans for manual testing, you can create plans for technical control testing that is automated, you can create plans for annual, monthly, different plans, and they're all machine readable as well. What we can also do is all the 853A directives are also in the catalog, which are pulled into the profile, and we can go to the SAR and auto build out the SAR to the granularity that the assessor needs to document. And to that extent, now the assessor also knows what is everything that I need to do. And so by standardizing this in your organization, you just make sure that, you know, you improve the quality of the work in the sense it's getting done. And then you can create templates of your plans, you can create templates of your results, and you can start populating that. And if you have an inheritance model and you're inheriting controls, I can already go to your SSP and say, okay, you said that you're inheriting these controls. Let me go pull the assessment of those controls and see if I can inherit the assessment. Or perhaps I'm going to come back and tell you, I'm sorry, that particular component that you're inheriting from is outside the assessment cycle, which means you're held up now. And all of this can be done in an automated fashion now. Now, OSCAL is designed to be a cross-regulatory framework, so it kind of stops at a certain point. And FedRAMP has extended OSCAL significantly. And they've added a whole lot of data elements to it. OSCAL is very flexible and extensible. But they've added a whole lot of data elements that are US federal compliance requirements. And so there's a whole lot of extension, both in data and business rules, that have been added by FedRAMP to that. And those baselines are also available from FedRAMP publicly. All right, so what this really allows for GRC tools now is to be able to automate a lot of this work end to end and be able to run validations on documents in an automated fashion. Because you have a standardized data fabric. Without a standardized data fabric, you cannot do that. And it's interoperable as well. So we're proud to say we have done a pilot. We're the first and only platform out there that has done a full ATO package in OSCAL. We submitted it to FedRAMP. They ran their automated validations. They've coded thousands of rules that they look at ATO packages when they come in. And they run it against this whole ATO package, and they can tell you right away what's wrong with the package before a high-value person reviews it. So all of that is automated. And FedRAMP is looking to launch an API as well, So CSPs can now automatically transmit compliance information, and FedRAMP can run an automated test and say, I'm accepting it for review or I'm rejecting it before review. And so we completed that pilot last year with a couple of companies. And that's about it. We're in booth 2 if you want to know more. Come chat with us.